All right, today we are going to show you Mark's clean lift method. This is the fastest way that you can solve your pervasive iPhone 7 audio IC problems. So what do we mean with audio IC problems in the iPhone 7? Mark, you've got a phone in front of you that's sent in by fellow YouTuber, Gear Down for What, and I love what he's done with this. So this is his phone, and he's put googly eyes on it, X eyes, and he made a sad face lock screen. And Mark, so do you feel that his phone is suffering from audio IC disease?
Yeah, 100%.
Why?
Well, for one, it takes a while to boot up, and if you go into the voice memos app, you don't have the option to record or play.
So voice memos is grayed out, and I think that's diagnostic for audio IC disease.
Yeah, I mean, every time I've seen it, that
right. So there can be a host of other features. So if you're wondering if your phone has audio IC disease, this is manifest by anything audio related in the iPhone 7 or 7 Plus, where it's a really common problem. So this means something where callers can't hear you or you can't hear the callers. Unusual things with loudspeaker or earphone, ear speaker. Something like the Siri can't hear you, something like you go to record a video but it doesn't record sound. So those are all features of the same exact problem. The underlying problem, I'll explain to you while Mark is taking out this board. The underlying problem is that the bendy, twisty iPhone, same for iPhone 6, 6 Plus, 7, 7 Plus, all of these iPhones have a little bit of give and bendy, flexy stretch to them. So if you think about, kind of kids jumping on the bed, I like this little thing, which I think is very fitting for this channel, because this YouTuber's channel is all about 3D printing cool stuff, and my son's just signed up for whatever robotics is. I bought a 3D printer, and it came with this cool little thing, which I thought was an excellent little doodad to illustrate the inherent defect in iPhone 7 audio disease. So what happens is the logic board itself, when it's screwed down inside the housing of the phone, it's subject to all of those bendy, flexy forces, kind of like kids jumping on the bed. And over time, just like bending a paperclip back and forth, back and forth, back and forth, back and forth, you end up getting little tiny weaknesses, lengthenings, pulling up floppy pads under the audio IC itself. So unfortunately, the line that's affected, the one that's on the very edge of the big fat square audio IC chip that we're getting ready to see, the one that's affected is the C12 trace. Now that codes for the audio master clock line. The master clock line is going to be a frequency line that all other signals that the audio IC generates and receives has to be interpreted based on this master clock line being good. And so if the master clock line is kind of fritzy, it makes the entire chip kind of fritzy. So all of these audio functions are then potentially affected by the same underlying problem, which is the C12 pad is floppy underneath the audio IC. So what's the fix?
Put a jumper.
So Mark is going to strengthen the audio, the floppy pad there, the C12 pad. So you're going to keep this audio IC that's native to this phone. You're not going to replace it.
Right, there's nothing wrong with the chip itself.
Right, so that's part of this, your clean lift method. Your goal is going to be to lift up the audio IC, preserving the underlying balls that the chip sits on. So if you do it right, then what?
Then I will have an even split of balls on board and balls on chip.
Yep.
And none of them will have bridged or combined.
So you're trying to do like a half castration.
Yeah.
All right. So hopefully that will go well. Now if it doesn't, and you end up with kind of not a clean lift, a perfect clean lift, you get a sideways lift, then what are you going to do?
Then I have to reball the chip.
No choice but to reball it, because at the end of the day, the balls have to be perfectly even, Steve. Let's see if we can kind of get this above you. All right, so I'm not as good as everyone around me at doing the hand count. All right, so what are you doing now? I'm going to switch you over to microscope view. Let's take off desktop. Tell us what you're doing right now.
Right now, I'm reforming my clean lift tweezers because last class some students used them. And
Oh, you made the grave mistake of letting students touch your tweezers. So what do you
Yep.
mean reform?
So I want them to be hooks like this, like that.
Hooks.
So got little hooks that are going to
Yes,
hook
so
down
you
under
made
the chip.
your beautiful $50 tweezers into crochet hooks,
Yes.
and you're not using the preheater right now. So
Right.
Why is that?
Because I want to have this chip come off with the smallest amount of heat possible. So the way I'm going to do that is just hook under the chip, lift the board slightly off the table, and then apply
So you're
just hot
holding
air.
the entire board up by the chip right now.
Yep.
Now this is the same way I do it, but I do preheat. I do it on the preheater, and I always reball the chip.
Mm-hmm.
Because this is, you gotta have some cojones to go with the clean lift method.
Yeah. If you mess this up, then you're reballing baseband for sure.
All right, so how did you do? Show us your balls, Mark.
All right. Let's see. So yeah, we've got.
We can't see.
We got most of the balls stayed on the board. A lot of them split and half the ball is on the chip, and then some of the
Now,
balls.
are they rounded or are they pyramids? I mean, from here it looks like.
They're rounded because I applied
Okay.
flux before I lifted.
Okay.
That's another part of this technique. If you're going to do it, you want to apply flux. That way you don't end up with pyramids on the board.
Right, that'd be mighty hard to balance the chip
Yeah, you would.
on,
I mean, you
on
could.
inverse pyramids.
You could go in and just hot air those to.
Okay. Make
Tighten them
some
back up.
Skittles for them to sit on.
Yeah.
Okay, gotcha.
So now I want to touch up any pads that look oxidized on the chip.
All right.
There's
Touch
always-
up pads that look oxidized on the chip. Now, why is that important?
So that I can be sure that I'm going to make a good bond when I put this chip back on.
Okay. All right. So these are the dull gray looking pads. You're not putting flux on that?
Usually there's enough left over that I don't have to add more, but I'll go ahead
That's
and
kinda
add a little
dry.
bit.
All right. So you are, and this is why you can't just reflow these jobs. Just reflow, it'll be fine, because of the fact that you really can't make joints between two oxidized pieces.
Well, yeah, that, and you can't address a break in a trace by heating the board up.
Right. All right. Let me see if I can edit our microscope cam to stop trying to green screen. There we go. Right, got it. Okay. So now you're just doing the ones that are flat where all of the ball is on the board right now.
Yep, just the ones that are flat and oxidized.
All right. Hughes Tech Services. My daughter was surprised when she saw the voice memo button light up and read after replacing her audio IC chip. Oh, light up in red so that you could use it. Yes. All right. Okay,
All right.
so
So now,
what about so let's see the underlying problem. Where is the C12?
right here.
All right, it's a little bit out of focus. Can you straighten up our camera, our microscope focus? There you go. All right, so why is it that C12 is affected? Well, it's right at the bendy spot, which is that vertical line by the sim tray, and that C12 pad is floppy. It's kind of been lifted up. It's loose. It's no longer really adhered down to the actual substrate of the board like a normal one. Now, why C12 and not any of the rest of them? So if you look closely at these spots, most of these pads are attached like a lily pad on a stem, where the stem goes down, vertically down into the board. So that doesn't experience the same kind of stress that the twisty, bendy, bending a paperclip sort of phenomenon that happens with these like C12 that have their trace, the way they're connected to the board, extending from the side. So C12, as you look at it, it is the closest pad with a side trace that is closest to the edge of the board. So you can see that Mark is now beefing up or enhancing that sideways C12 trace, the master clock line that goes from the ball to that adjacent resistor. That's the spot. That is where you have this floppy malconnection. And so he is adding a piece of jumper wire. And what was your jumper wire that you were using just there?
That came out of a iPhone 4S vibrator motor. Love
Right,
that
Tony
stuff.
Tone asks, why not, Mark, just scrape away the trace and solder up the trace? Quicker than Mark making a joke.
That's another way you could do it. I can't think of a reason why that wouldn't work, but I make the jumper. I feel like that's quicker for me.
I don't really see how soldering up the trace is preventing the problem from recurring, because it's already it's a trace that got damaged. I think the wire is what makes it so that that's lifting, pulling doesn't just break the trace again. That wire is way thick compared to the trace itself. I mean, what do we know about the trace? It got damaged.
I think the argument could be made that if you're tinning the entire length of that trace and adding solder, you're making it significantly thicker with the solder.
All right.
So
this microscope can away. And bring back. Here is Mark. All right. So now you're getting out the preheater. Why the preheater now?
because it's going to take a lot more heat and time to get this chip back on the board than it took to get it off.
Okay.
So I'm
And
wanting
what does
now.
the preheater do?
The preheater gets the board up to a temperature that is not enough for even leaded solder to melt, but it gets it up to a higher temperature that allows me to use a lower temperature on my hot air and spend less time in there with the hot air.
Okay. And I like the idea that what you're trying to avoid is creating a problem at the adjacent chip on the bottom side of the board, the baseband CPU, which doesn't like heat because it's surrounded by underfill. And so that chip on the bottom side of the board is subject to overheating and just kind of making poor connection between the balls of that chip and the traces that it's supposed to sit on, all of those pads. So I think that when you bring it up to temperature in a slow controlled fashion, that ends up allowing it to sort of off-gas in a way that the heat that you're applying doesn't just create a big pressure and a big explosion and pop those balls off of their pads.
Yeah,
At least
that's a good
my
point.
theory. Alrighty.
Yeah.
Alex says that he avoids going down the trace so that the jumper has an ability to flex. In his opinion, down the trace would be too rigid and cause issues. You know, I think that just soldering down the trace, it's certainly not as thick as, or it's not as robust and strong as wire would be. And then we just know this flexion damage is just so rampant. And it is, I made this model that I really like that I'm going to do another blog about, where if you take two Legos and kind of stack them, two thin Legos, and stack them on each other. Here's Mark under the microscope. And then you start bending them as if they were in an iPhone, you can really see how the edge of the Legos just come unsnapped. And I think that really kind of is a good model for this problem and the kind of forces that are really pulling up on this trace. So I don't like the idea of just kind of glossing over it with solder. I don't think that's going to solve the problem of the chip, this chip pulling up on that pad. But if you really wanted to do it that way, you could give it a try and then just see what happens by having a long warranty. See if they come back. If they don't come back, then practical repair says that's the way to do it. So you're applying heat now that's quite low.
Yes.
This is quite low. This is 315 degrees on the JVC. And I would normally operate this JVC at more like 370 or even 380. Alright. Would it be more useful to have a generic board heater with a larger footprint to cover more sizes of boards? I don't know. I like this one, and in my experience, when we get something that we like, then unless there's a problem, we kind of stick with it.
think I might want like 5 more degrees on there.
Alright, I gave you some more degrees.
Alright.
You want more flux?
No, I think I'm good on the flux.
Alright.
There we go. Oh no, I feel like she's not quite perfect.
Not quite perfect.
Yeah.
So you're tapping it on the other side where you can't see.
Yeah. Just giving it the little nudge.
The imperceptible nudge.
Yeah. I think
Okay.
that's going to be okay.
Alright. So now what are you going to do?
Now I'm going to let it cool down.
Okay, so do you let it cool down on the preheater or take it off?
I've let it cool down for just a minute or 2 on the preheater to make sure those balls have solidified again, and then I'll take it off to let it cool down a little faster. The preheater takes a while.
Okay. Alright, so that is... I have to get putting this in recovery mode. I'm trying to do like 3 repairs at one time while streaming. Alright, so this is the Mark's cooler method. The official...
Well, it's like when you blow on your dice at the
Yeah.
at Las Vegas.
Yes, exactly like that. Alright. Okay, Alex is asking only C12. What do you think about that?
I think that there was a time when we thought, you know, it was reasonable to say all of these ones with side traces
Right.
are going to be susceptible to the same kind of damage, so let's fix them all. But then we put it to the test and left long wires connected to each one of these and found the only one that actually causes problems when you ground it is C12.
Right. I mean, I think that the community sometimes, kind of does things just out of habit. So do you, when you're fixing a touch disease, where we know for sure the problem is M1, do you put jumpers on all the other pads in that top row?
No.
Right. I don't either. Now, I would solve that by honoring any kind of warranty issue that came back for any kind of touch defect, and we just don't see that. So we haven't, we put a micro jumper at the affected trace, M1, for touch disease, and this is another kind of instance of the same exact thing, which is flexion-based damage. So our experience from the flexion-based damage is that M1 is affected. The other adjacent traces that could be affected that also have these sideways, potentially lifted off traces, they don't seem to get torn in a way that makes them electrically inactive the way M1 does. So here at Audio IC, while you can see a potential for problems along the entire line of C12 and everybody else in that line, so we're going to try to boot it up and see what the deal is now. It seems to be from our experiment where we look to see what feature effect, what would be the practical effect that you would see if you had a loss of signaling in any of these other lines. And we didn't see any effect. So you can two of them, high pass filter or something like that. All right, so that was a relatively quick boot up.
Yep, normal boot up.
And now you're going to do what test?
I'm going to see if we can record a voice memo.
All right, and what are you going to say to this guy?
Yay, it works.
Yay, you can take the X's off of my googly eyes. Hooray. Get up the alcohol. Make him have make his lock screen be a happy one.
I was going to say, we're going to have to change his lock screen now so it's happy.
Yeah, and then just go ahead and alcohol off his eyes so that he has happy eyes. All right, fantastic. All right, why don't you hit stop and play that back so that we can hear that it has audio function. So right now we can tell that it works. Yay, you can take the X's off of my googly eyes. Hooray.
All right.
All right, so we wanted to keep this video nice and short, and that is how we approach the clean lift, quick as possible method of your audio IC repair on the iPhone 7. And if you need a repair, you can find us at iPadrehab.com, our brand new website, and click Mail and Repair. You can also find us on Instagram and check out what we've been working on lately. You can find us, here's our website is demoted. Here's the website. If you need training, then you can come hang out at Practical Board Repair School with the students. Find it again on iPadRehab.com, click training, and come and join us. We're going to do a fun one. We've got a really fun stream, hopefully planned for this week. The students don't know about it yet. And we're really excited. They are going to solve a phone that another well-known data recovery company failed to solve on an $1,800 quote. It was sent here to iPad Rehab, and we are going to have the Practical Board Repair School students for this week fix it. So we're really excited about that, and we're going to cut this one short. We will see you next time.